Good morning, students. Myself, Vijay Shankar from EC Department, Chevrolet Engineering College. Today, we are going to discuss about Z transform examples. So, what is the definition of Z transformation, and what are the different types of properties and the different types of the properties of ROC? We already discussed in the previous classes. Now, coming to the some examples on the Z transformation using the properties and the definition of the Z transformation. So first example, calculate the Z transform of the below. Calculate the Z transform of the below signals. So one is x of n is equal to, it given in the sequence 3, 2, 1, 0, 5. So without any arrow mark is represented in the sequence, the first value is at n is equal to 0. X of n signal is a 3, and n is equal to 1. The x of n value is a 2, and n is equal to 2, the x of n value is a 1, and so on. Okay, and now take the definition of the Z transformation. X of z is equal to sum of n is equal to minus infinite to infinite. X of n z power minus n. X of n z power minus n. That is sum of n is equal to minus infinite to minus 1. So why are they taking the minus 1, minus 1 to minus infinite to minus 1? Actually, the value is for the negative values is a 0 here, and it starts from the 0 to 4, and 5 to 5 infinite also the values is a 0. So before the values of n is equal to 0, and after n is equal to 4, the values the given in the sequence is a 0. That they are representing here. Minus infinite to minus 1, the value is a 0 here. And plus 5 to the infinite, the value is also 0. Got it, my students? So in between the values when n is equal to 0 to 4, x of n z power minus n. X of n z power minus n. So expand this value. When n is equal to 0, it becomes of x of 0 into z power 0, x of 1 z power minus 1, x of 2 z power minus 2, x of 3 z power minus 3, and x of 4 z power minus 4. Okay, we already know the given sequence x of 0, 1, 2, 3, and the 4 values are 3, 2, 1, 0, 5. Substitute here. And x of 0, the 3 value, z power 0 is a 1, x of 1 is a 2, and 1 by z is a z, my dear students. Don't think it is a 2, it is a z. And when x of 2 is equal to n is equal to 2, the value is a 1, and 1 by z square. And n is equal to 3, the x of 3 value is a 0 by z cube. X of 4 at n is equal to 4, the value is a 5, 5 by z power 4. Okay, now I can simplify. 3 plus 2 by z, 1 by z square, and this value is a 0, 5 by z power 4. Take the LCM as a z power 4, 3z power 4, 2z cube z square plus 5. Okay, now in this equation, what we got here, the Z transformation, when z is equal to 0, when z is equal to 0, the total function x of z becomes of infinite, because anything by 0 is an infinite number. What it matters, students? So except z is equal to 0, except z is equal to 0, the entire z plane is here. Entire z plane except z is equal to 0, the given, or the not the given, this function x of z is existent. Entire the z plane except z is equal to 0. The ROC, the region of convergence, entire the z plane except z is equal to 0. For the given sequence x of n, we got the function x of z is equal to 1 by z power 4 into the function the z we can take as a z is equal to 0, the function becomes infinite, except this value for remaining all the values of z is existent. Nothing but it is a finite value you get. Got it, my dear students? And we take this from 0 to infinite only. So always it is a unit circuit. But here the only the z is equal to 0. It is not existent, but remaining all the values is existent. Got it? The second here, another sequence is there. 3, 2, 1, and 0 arrow mark is given here. This arrow mark represented this value is n is equal to 0. You see here. And n is equal to 0, the value is 1. N is equal to minus 1, the value is a 2. N is equal to minus 2, the value is a 3. And n is equal to 1, the value is a 0. N is equal to 2, the value is a 5. So with these values of x of n is equal to and x of n, the function, substitute in the definition of the z transformation, x of z is equal to sum of n is equal to minus infinite to infinite x of n z power minus n, and sum of n is equal to, he can take the range only. The previously we take the minus 1 infinite to minus 1 and the 5 to infinite also. That values is a 0. So in this also minus infinite to minus 3. The value is a 0 here. And 2 to not the 2, 3 to infinite in the range the value is a 0. Only we have the values from minus 2 to the 2. So n is from minus 2 to the 2. X of n z power minus n. Expand the value. X of minus 2 z power minus of minus 2. It becomes of z square. X of minus 1 z power minus of minus 1 z power 1. And x of 0 z power 0. X of 1 z power minus 1. And x of 2 z power minus 2. So the first term is x of minus 2 by substituting the value of n is equal to minus 2, the value is a 3 into z square, and here the 2 is a 2 into z, and at the 0 the value is a 1 into 1, and at n is equal to 1 the x of n value is a 0, this term, and 5 into z power minus 2. So 3z square, 2z, 1, and this value is a 0, 5 by z square. 5 by z square. Check the LCM here to get the x of z. 1 by z square we have. Now we can substitute z is equal to 0. Z is equal to 0 here. The entire function, it becomes of infinite. X of z is equal to infinite. Got it? Or otherwise, if you take this function, x of z, now z is infinite here. If you take the z is equal to infinite, last term becomes a 0, and this value becomes of the infinite term. So x of z is also infinite when z is equal to infinite. Got it, my dear students? But here also you can observe that when you can take the previous equation in the x of z, whenever if we can substitute the z is equal to 0 only, the last 3 terms becomes infinite. The first term is a 3. The 0 is infinite. 3 plus infinite, again it is infinite only. But in this equation only, the last term becomes is a infinite. 5 by the infinite. 5 by the infinite becomes a 0, and the remaining the 2 terms becomes infinite. So the entire the z plane except 0 and the infinite. Previous condition, entire the x plane except the z is equal to 0. But for these given equations, the ROC, the region of convergence, is entire the z plane except z is equal to 0 and z is equal to infinite. And the remaining all the values, the function is existent. It is not getting the infinite, it is getting the finite value only. What it might have, that is the ROC. How we can find the ROC means the function x of z what we have. You can substitute the z values. It is not equal to the infinite. Then only it can exist. If it is infinite, it is not in the region of the convergence. It is unbounded. It is not in the bounded conditions. Got it? Next example. Third example, x of n is equal to 0.5 whole power n mu of n. 0.5 whole power n mu of n. We already know a power n mu of n. The function is 1 by 1 minus a z inverse. 1 by 1 minus a z inverse. What is the a here? 0.5. 0.5 is nothing but 1 by. Okay. So according to the function a power n mu of n, the z transformation is a standard z transformation. 1 by 1 minus a z inverse. With ROC, the region of convergence z is greater than a. Got it, my student? This is given only this function, or otherwise directly don't use this one when they given in the 3 marks or the 4 marks question. It's a 1 bit question means then only you can write directly the a power n mu of n is a 1 by 1 minus a z inverse. Instead of a is a 0.5, 1 by 1 minus 0.5 z inverse directly can write it. But if they ask in the 3 marks and the 4 marks means you have to show the procedure. You have to substitute in the given x of n in the definition of the z transformation. Then you can simplify and finally you have to show the answer. Got it, my dear students? Now for that I am taking here the x of z is equal to sum of n is equal to minus infinite to infinite x of n z power minus n mu of n is substitute the a power n mu of n. Mu of n is only the right side function. So I split the two parts as minus infinite to minus 1 and 0 to infinite. Minus infinite to minus 1, the values becomes a 0 here. You see here, 0. And 0 to infinite, 0.5 whole power n z power minus n. The mu of n value is a 1. So 0 to infinite, 0.5 is a plus power and z power minus n. So both you can keep that as 0.5, nothing but is a 1 by 2. Inside you can keep that is a z power minus 1 whole power n as sum of n is equal to 0 to infinite. This is the equation actually. We know the formula sum of n is equal to n1 to n2 a power n is a power n1 minus a power n2 plus 1 by 1 minus a, and a is greater than the 1. In that we can substitute the value is, or you can expand. Here the expansion is there. A plus AR plus AR cube and AR power 4 and A power 5 and so on. That is 1 by 1 minus R. Got it, my dear students? Now I am using this a function. When n is equal to n1 to n2, a power n is equal to a power n1 minus a power n2 plus 1 by 1 minus a, and you have to have the conditions n2 is greater than n1 and a is less than the 1. A is less than the 1, my dear students. Using this formula in this equation, instead of a is 1 by 2 z inverse, n1 is a 0, n2 is a infinite. That is equal to a 1 by 2 z inverse whole power 0 minus 1 by 2 z inverse whole power infinite plus 1, because n2 is infinite here, whole divided by 1 minus 1 by 2 z inverse. A. And what is the A here? 1 by 2 Z inverse is less than the 1. As a condition you have to satisfy. So anything power 0 is a 1. Anything power infinite is a 0. Whole divided by 1 minus 1 by 2 Z inverse. 1 by 2 Z inverse. Nothing but the value is 1 by 1 minus 0.5 Z inverse. Okay. So we got this function a power n v of n is 1 by 1 minus a Z inverse. Instead of a here 0.5. Directly we got x of z is equal to. But what is ROC? What is ROC? 1 by 2 Z inverse is less than the 1. So 1 by 2, nothing but is a 0.5 by z is less than 1. Okay. 0.5 is less than the z. And z is greater than a, greater than 0.5. See, this ROC we have. Similarly, z is greater than a. What is the a? 0.5. Okay, z is greater than a, nothing but is a 0.5. The ROC is outside the circle of with the radius 0.5. With the radius of 0.5 is a totally outside the circle 0.5, the region of convergence. For all the values of greater than the 0.5 of the circle, the x of z is exists. Nothing but is a bounded. Remaining all values is not bounded function. Okay. You see here the z is greater than 1 by 2. And x of z is 1 by 1 minus 1 by 2 z or 1 by 2 z inverse. Okay. And next one, x of n, the 0.5 whole power n mu of minus n minus 1. Mu of minus 1 minus n minus 1 is a right sided. Is a 0.5. A power n mu of n is a right sided. Nothing but towards right handed. Right sided. Okay. Now the mu of minus n minus 1. Actually, the mu of minus n is nothing but left sided. Because it is a discrete, 0 to infinite is in the right sided means minus infinite to minus 1 is the left side. The range here the 0 to infinite. 0 to infinite is a right sided and minus infinite to minus 1 because it's a discrete. Minus 1 value is a left sided function. Okay. So mu of n is equal to 1 with n greater than or equal to 0 and 0 is less than 0. And mu of minus n minus 1 is 1 when n is here. Minus n minus 1 is greater than or equal to 0. Minus n minus 1 is greater than or equal to 0 and n is less than or equal to minus 1. Less than or equal to minus 1 means it is a range is from minus infinite to minus 1. Only the value is a 1. What it matters? The solution here, substitute in the x of z. Sum of n is equal to minus infinite to infinite x of z, z power minus 1. Z power minus 1. Now you can see it is a 0.5 only they given, but the derivative is a 0.8 here. Okay, right, that is a 0.5, or otherwise you can keep that 0.58 only. Nothing is wrong there. It's a 0.5, and here also it is a 0.5, and this also is a 0.5, and this is a 0.5, and here is a 0.5. Got it, my students? Now I am substituting in this equation. So second term, whatever we have, that is a 0 because it is in the left sided sequence. Minus infinite to minus 1 x of n z power minus n. Minus 1 infinite 1 minus 1 0.5 whole power n z power minus n. Now here one you have to remember, I'm changing the limitations as negative to the positive. Changing the limitations of the n values and negative values to the positive values, both values. Change the powers are positive to the negative, negative to the positive. So minus 1 is becomes a plus 1 here, minus infinite is becomes a plus infinite, and 0.5 whole power plus n is minus n, and here the minus n, z power minus n is becomes a plus n. So limitations in sign is changes, the power is also changes in that summation. So sum of n is equal to 1 to infinite, because it's a 0.5, derive this 0.5 whole power minus n, z power n. Okay. Now we can change this as a 0.5 whole power minus 1 whole power n, nothing but 1 by 0.5. Okay, I will show this in this term only. So 1 by 0.5 whole power n and z power n. I'm changing this negative by keeping the 0.5 in the denominator. So write this function totally, the 0.5 whole power n. Now it is in the form of a power n only, in the range of infinite to 1 or 1 to infinite. In the substituting the formula what we have, the a power n, sum of n is equal to n1 to n2. n1 is a 1 here, n1 is a 1. So z by 0.5, z by 0.5 whole power 1 minus z by 0.5 whole power infinite plus 1 whole divided by 1 minus z by 0.5, and this z by 0.5. Z by 0.5, the value is less than 1. This is a condition we have. When it is in the form of sum of n is equal to 1 to infinite z by 0.5 whole power n is equal to. Okay. So that you can simplify the z by 0.5 because it's a whole power 1 minus anything power infinite is a 0 whole divided by 1 minus z by 0.5. Okay. Take the z by 0.5 is a common in the denominator, numerator is get cancelled, and 1 by the z by 0.5 minus 1. So actually it is in the form of minus is there, my dear students. Actually this is a minus 0.5. Then it is a correct. It's a minus, and keep this a minus here. The total function is equal to, and this is also minus. The total function is equal to. So multiply this minus inside the function. Now it becomes of 1 by 1 minus, because the minus 1 is becomes a plus and this term is a minus. So 1 by 0.5 z inverse. What minus? Not the 1 by 0.5. That is a 1 by z by 0.5. You get in the numerator. This term is get in the numerator. It's the 0.5 z inverse. Okay. So same function we got x of z is equal to 1 by 1 minus 0.5 z inverse. Okay. In the previous, when we take the 0.5 whole power n v of n, the value is the same. Here see the x of z is equal to, is a function 1 by 1 minus 1 by 2 by z. 1 by 2 the z here, z inverse. Here also it's a 1 by 1 minus 1 by 2 z only. But ROC is a difference. What is ROC here? Z by 0.5 is less than 1. Z by 0.5 is less than 1 means z is greater than, not the greater than, less than 0.5. Less than the 0.5, the ROC. Means inside the circle. The circle with the 0.5, the ROC is inside. The previous case is outside. Inside means the left side in the S-line. When we consider in the circle, inside the circle, all the values of the inside the circle, the function is exist. The remaining all the values, it is not exist. Got it, my dear students? Modify this as a minus 0.5 mu of minus n minus 1. Remember this one. Both the functions, what we given the 0.5 whole power n and minus 0.5 whole power n mu of minus n minus 1. The function is the same. The x of z function. X of z function is the same, but ROC is a difference. For ROC is greater than 0.5 here, and ROC is less than the 0.5. Okay. Clear, my dear friends? Then go to the another example. See, we got the z by z minus 1. You take the common of the z here, and minus 1 minus 0.8. They're taking the 0.8 is there. It's not the 8. With a little bit confusion, take the 0.5 only. 1 by 1 minus z inverse only. But ROC is less than. Z is less than the 0.5. Okay. Other example, n into delta of n. N into delta of n. What is the delta of n? Delta of n is having only the one value. Either the continuous function or the discrete function. And discrete is represented and continuous is represented the same way. 1 for delta of n with the change of the variable of a t to n in the discrete. Okay. The given the function is n into delta of n. So you substitute in the z transformation definition, x of z is equal to sum of n is equal to minus infinite to infinite, x of n, z power minus n. What is the x of n here? Sum of n is equal to minus infinite to infinite. X of n is n into delta of n, z power minus n. Okay. In this range, we have only one value for the delta. So it becomes of n into delta of n, z power minus n at n is equal to 0. The remaining all the values is becomes the delta of n is a 0. What is the delta of n when n is equal to 0? 1. So 0 for n is a 1 and z power minus 0. The total function is a 0. So x of z is a 0. What is ROC? The entire the z plane. For any values of z, x of z is a 0. No change in the function of x of z for any value of z. So the ROC is entire the z plane. Entire the z plane. So x of z is equal to 0 for n delta of n. If it is a delta of n, the value is 1 because there is no any n multiplied. X of n is equal to, and x of n is equal to delta of n. The transformation is becomes of 1. It is also finite value only. It is also finite value. Here also the ROC is the entire z plane. Got it? The similar way, the x of n is equal to delta of n minus 4. Even it is shifted towards the right side and shifted towards the left side, the value is the 1. The value is a 1 for the delta. Okay. They're asking here the x of n is equal to delta of n minus 4. So delta of n minus 4 shifting towards the right side with the 4 samples. So now it becomes of the 0, 1, 2, 3, all values is a 0 because it shifted towards the 4. Add to 4, the value is a 1. Okay. Now, in the definition of x of z, delta of n minus 4, so sum of n is equal to minus infinite to infinite. x of n z power minus n. So what is the delta of x of n given? Minus infinite to infinite, the delta of n minus 4 z power minus n. So the delta of n minus 4 h, the n is equal to 4 only. Okay. So z power minus n at n is equal to 4. And here the delta of n minus 4, you can also write at n is equal to 4, the value is of 1 and z power minus 4 becomes of 1 by z power 4. So here, z power minus 4. And now, when 1 by z power 4, except z is equal to 0, except z is equal to 0, all the values is exist here. Because whenever the z is equal to 0, you can substitute 1 by 0 is a infinite. The entire the z plane is a ROC, except z is equal to infinite, not the infinite 0. Okay. Similarly, the delta of n plus 3. Delta of n plus 3. Even these also the n plus 3 means at n is equal to minus 3 towards the left side. You can see the 0 delta of n plus 3. Plus means advanced function. Minus 1 is a 0. Minus 2 is also 0. And minus 3, the value is 1. Because it is shifted towards the 3 samples left side. Coming to the definition of x of z, delta of n plus 3 z power minus n at n is equal to minus 3. N is equal to minus 3. The value of delta of n plus 3 is a 1 and at n is equal to minus 3 and z power minus of minus 3 becomes of z power 3. So x of z will get for the advanced function and shifted towards the left side with the 3 samples, z power 3. But what is ROC? ROC is towards the left side means less than the infinite. Except the z is equal to infinite, entire the z plane is the ROC. Except z is equal to infinite. Remaining all values you can take x of z becomes a finite value. Except z is equal to infinite, the remaining all the values of z, the function x of z is exist. Delta of n plus 1, n plus 3. Coming to the y of n here, another example, x of n plus 1 into v of n. X of n plus 1 into v of n. Okay. Now I am taking here the given function, substituting the z transformation definition. Sum of n is equal to minus infinite to infinite. X of n plus 1 v of n as the function and z power minus n. What is the v of n? The range is changes from infinite to 2, minus infinite to infinite becomes of 0 to infinite. X of n plus 1, v of n is a 1 and z power minus n. According to the shifting property, you can write, or otherwise, let n plus 1 is equal to p. And what is the n is equal to p minus 1? Substitute here. And when n is equal to, here also change the limitations also. When n is equal to 0, because it's the first limitation here, n is equal to 0. What is the p is equal to 1? When n is equal to infinite, p is equal to infinite plus 1 is becomes nothing but infinite only. Got it? So, the function now changes to the n as a p values. P is equal to 1 to infinite. X of n plus 1 now it becomes of the p and z power minus n. N is nothing but p minus 1. P minus 1 here. Okay. Is equal to sum of p is equal to 1 to infinite x of p z power minus p and z power minus of minus 1 is a 1. Okay, my dear students. So now we can add the x of 0 to the infinite or the 1 to the infinite. I got the unilateral z transformation. This function is x of z only. Okay, minus becomes x of z into x of z. Z into x of z. Got it, my dear students? One of the property, shifting property, saying that x of n minus m, the z transformation is for positive values of m, there is a negative powers of z and multiplied with the x of z, unshifted z transformation. Now it is a n plus m for negative values of m. The transformation is z power m, positive z power and x of z. What is the m here? Instead of m, there is a 1. So x of n plus 1, the transformation is directly you can write as m is equal to 1, the z power 1 and x of z. Got it? Is directly you can write for the online bits, but when they're given in the 3 marks or the 4 marks means I have to show this total procedure to get z x of z. Got it, my dear students? If n is n, x of n plus 2, z square x of z. If n is n plus 3, z cube x of z. Okay. So next example. Here we got the z minus x of 0 also, because if it is a unilateral, definitely can add or subtract from the minus z into x of z according to the definition, because a one-sided z transformation only we are considered. You see here, the function is a p is equal to 1 to infinite x of p z power minus p minus 1, and that is equal to sum of p is equal to 1 to infinite x of p z power minus p and the z. Now I am subtracting x of 0 z power minus 0. X of 0 z power minus 0. So the z into x of 0 is also subtracted. Got it, my dear students? So actually, how we got that function means, see what is p is equal to 1 to infinite x of p z power minus p into z. So unilateral z transformation means it starts from the 0 to infinite. 0 to infinite. So I'm adding the function here, sum of p is equal to 0 to, or the p is equal to 0 to the value. P is equal to 0, otherwise you can write this as a function of x of 0 z power minus 0. Got it, my dear students? X of 0 z power minus 0. I'm adding that and subtracting also. X of 0 z power 0. Adding and the subtraction. Got it? So x of 0 z power minus 0 means the p is equal to 0, the function is the same. So I'm rewriting this function as a p is equal to 0 to infinite x of p z power minus p into z is also there. The function, there is a z is there. For this function is multiplied with the z, and totally this function is also multiplied with the z, and this function is also multiplied with the z. Already we have z power minus p and z power minus of minus 1 is a z is there, my dear students. I take only this function, I am rewriting this p1 to infinite as a 0 to infinite by adding and subtracting of x of 0 z power minus 0. Okay. Total function is multiplied with the z minus x of 0. Anything power 0 is a 1. So x of 0 into z. So according to the unilateral z transformation, the definition of z transformation is from 0 to infinite only. Z into x of z minus z into x of 0 is a total function. Now whatever the y of z is here. See that only the wrote y of z is equal to z into x of z minus z into x of 0 also. Don't confuse. Okay. But unilateral, definitely there is a subtraction or the addition of the initial value conditions also. But bidirectional means only will get z x of z only. Z x of z only. Next, another function. X of n minus 1 mu of n. X of n minus 2 mu of n. So directly you can say, according to the formula, the 2 is positive value. 2 is a positive value. This is z power minus 2. Z power minus 2 into x of z is a bidirectional z transformation. But it is a unilateral z transformation if we can take, because of it is multiplied with the mu of n. Definitely there is a subtraction occurs. Subtraction of the addition values. Got it? So see, y of n is given x of n minus 2 mu of n, and the definition is minus infinite to infinite y of n z power minus n. And what is the y of n given? X of n minus 2 mu of n. X of n minus 2 mu of n z power minus n. And the mu of n is changes as limitations from 0 to infinite and keep the values 1 here. 0 to infinite x of n minus 2 z power minus n. N minus 2 is equal to p, you can assume, n is equal to p plus 2. Changing the limitations of n to the p value is minus 2 to the infinite. Minus 2 to the infinite. So substitute here the n minus 2 is a p and n is a p plus 2. So p sum of p is equal to minus 2 to the infinite x of p z power minus p z power minus 2. Got it, my dear students? Now z power minus 2 we can take as a common term, but the common multiplication factor. What is the function remaining here? The sum of p is equal to minus 2 to infinite x of p z power minus p. What is the before value of minus 2 is a minus 1. Minus 1 means x of minus 1 and z power minus of minus 1. Okay, so z power minus 2 we can multiply before the value if I am taking here. So here the p sum of p is equal to minus 2 infinite x of p z power minus p. So what is the before? Before the substituting the values of the p, x of minus 1 is a before value is a minus 1. Okay, minus 1. That minus 1 as not the minus 1 value, my dear students. Before you can go the minus 1, and here it is the okay minus 1 only. So x of minus 1 if I am taking, and the p value is also minus 1. So z power minus 1 it becomes of a z power 1. And what is this before value is 0. Okay, that 0 value. What is the 0 here? X of x of 0, not the 0, okay, 0 and the z power 0 value, minus 1 and minus 2, that is after value, my students. Minus 2 is there, means definitely that is a after value only. Don't think that is a before the value. Z into x of minus 1 and z square, when substituted, is a z square into x of minus 2 when after the expansion, and minus 2, minus 1, and the 0 is also there. What is a 0? X of 0 into z, x of 0 into the z value, and so on. So if we can add these two functions, I'm not taking this function here, only if I am taking this one, z power minus 2 and minus 1 and the minus 2 is there. It is also becomes of p minus 2. Minus 2 means is a minus 3 you have to take actually. Minus 1 z power 1 and minus 2 p were the value, and minus 2 to the minus 1 if I am taking, and 0 to infinite. Actually that we have to take them. So I am taking this one as sum of p is equal to minus 2 to the minus 1 x of p z power minus p plus minus 2 minus 1 we got, and sum of p is equal to 0 to infinite x of p z power minus p. This is the equation actually. X of minus 2 is there, x of minus 2 z power minus 2. So z power minus 2, we can expand these two functions as x of minus 2 z power minus of minus is becomes of plus z square plus, and x of minus 1 z power minus of minus is a 1. Got it, my dear students? Plus, and this total function, you see here, this total function is a unilateral z transformation only, x of z. Got it? That is the way we got it. Is in between only. Internally we have, but minus 1 and the minus 2 will take their functions, and 0 to infinite the another function x of z. Now I can multiply this function with z power minus 2 and z power square here. It becomes of x of minus 2 and plus, and z power minus 2 z power 1 is x of z power minus 1, because bases are same, we can add the powers. Minus 2 plus 1 is a minus 1. So x of minus 1 into z power minus 1 plus, and x of z into z power minus 2 is a function after expanding the y of z is equal to. So y of z is equal to x of z z power minus 2 and x of minus 1 z power minus 1 and x of minus 2. Got it? But what is ROC? ROC is because it is a mu of n, is greater than the 2 only. Greater than the 2. The ROC is greater than the 2 because its value starts from the p plus n minus 2 is there here. The function n minus 2 mu of n